Today I'm taking on a new type of challenge. We're calling this one Hello Sailor Joe versus ChatGPT. Hello people, Joe from Hello Sailor Effects here. Welcome to today's video. In today's video, I'm going to take on ChatGPT to see who can design the best Electra Distortion. Who comes up with this stuff? What? I'm taking on...
5 hours later.
This episode come about because I really wanted to film an episode on how to build a point-to-point or tagboard version of the Electra Distortion. But I was beaten to the punch by Josh Scott from JHS Pedals. He filmed this amazing series that no doubt you've all seen on exactly what mods you can do and all sorts of cool stuff. Cheers, Josh. Anyway, so I thought, how can I come up with something a little bit different? And I'm going to pit myself against ChatGPT. Can Hello Sailor Joe beat AI in designing an Electra Distortion circuit? Well, we're going to find out. In this episode, I use all my 15 years pedal building experience, most of which has been at sea in the Royal Navy, against ChatGPT to see who can come up with the best circuit. Stick around to the end and you'll hear my version against ChatGPT's version. Cheers. As previously stated, we're going to use AI to decide part of this circuit. So I'm going to use a nice R2D2 decal for this enclosure. We're going to have our volume control here. Then we're going to have switchable EQ. What am I talking about? We're going to have switchable diodes on this side. And then on this side, we're going to have a switch that takes either from the AI decided values and through to the normal values that I use in this circuit. I figured this would be a fun way to see if ChatGPT can make a pedal sound better than me. Now, of course, I'm not going to use everything that ChatGPT states, mainly because either I don't have it in stock or, mainly because I don't have it in stock. Also, I have tried to design circuits through ChatGPT. I'm pretty sure Chris Benson from Benson Amps mentioned this on TPS recently, that he tried to use ChatGPT to design a circuit, but it didn't quite get it working properly. So I haven't bothered with that. I just asked it specifically what capacitor values to use and why, basically. So without further ado, let's have a look. What are the best values and components to build an Electra Distortion for the best guitar drive tone? ChatGPT states, to build an Electra Distortion circuit for the best guitar drive tone while keeping cost in check, I didn't ask that, but I suppose it's being cost effective, you'll want to prioritise with a Z for Americans. Get in. It's actually spelled with an S, guys. You'll want to prioritise components that offer good sound quality without going overboard on the price. Actually, that's a lie. I'd like to go overboard on the price, but yeah, whatever. Here's a list of components and recommended values. So, ChatGPT says, Transistor, use a 2N2222 or a 2222 for my American friends, or a BC549C. Now I've went with the 2222 because that's what I have in stock. It says that these are widely available, inexpensive, reliable, and they sound classic in the Electra design. It also says for diode clipping, use 1N4148 diodes. They're great, affordable choice. And if you want something more vintage or a vintage tone, use 1N34A. Do you want to support this channel or even be as cool as a crusty old sailor? Check out our merch store below for cool jumpers, caps, t-shirts. Now, of course, I went with the 1N4148 just because I've got them in stock. Capacitors. It says for coupling capacitors and tone shaping, use Weimer film capacitors or Panasonic ECQ series. Now I haven't got any of them in stock and I didn't have a chance to order them before filming, so I have went with just whatever I've got. It says use values like 0.01 to 0.1 UF for tone shaping and 10 UF for power filtering. Now, this circuit hasn't got any power filtering, so I'm not going to use anything. This is where ChatGPT gets it wrong. So it's telling me to use a 10 UF for power filtering, but the circuit I'm using doesn't have power filtering, so we'll scratch that. And also 0.1 to 0.01, so 100 NF to 10 NF
if you like. That's a wide range. So I ask you further questions later on. It also says resistor wise, use 1/4 inch carbon film resistors because they're cost effective, work well in most pedal builds. Metal film can offer lower noise, but isn't crucial for this circuit. Now I've just went with whatever resistors are in place, although one of the resistors I've went with carbon film in the AI one because it suggested it and I had it, which is the 2.2 meg resistor. And in my own build, the comparison build, I'm going to use a vintage carbon comp. Now, potentiometer, 100k log pot. Yep, I've got that. Let's see what else it says. Enclosure, I've got my own enclosure as you see. And it says, actually says, by focusing on these reliable, budget-friendly components, you'll get great drive tone without overspending. Fantastic. So if you're thinking about building yourself something cheap, then why not? I went a bit further now and I asked ChatGPT what are the best actual values for the input and output caps. I actually spelled output wrong there, get in. Well done, Joe. ChatGPT answered, for the Electra Distortion, the input and output capacitor values are critical for tone shaping. Well, they're the only capacitor values and there is no tone circuit, so well done. Especially in terms of frequency response. Yeah, well done. Here are the best actual values commonly used. So it says input capacitor 0.1 UF. So we're sticking with the standard that's on my schematic. That's what we're going to do. Output capacitor 1 UF, which is way bigger than I would put it. And it gives a reason of. This value is standard and ensures full frequency response on the output side, allowing both high and low frequencies to pass cleanly without introducing too much bass. Right, so for me, the way I would use a larger capacitor like that, I wouldn't put it on the output, I'd use a 0.1 UF. But if I wanted to manipulate the bass, I'd put the bass on the 1 UF on the input. That would allow more bass into the pedal, which would mean that the transistor's amplifying lots of bass. So you get like a low, flubby bottom end, bit like a fuzz or whatever. So that's how I would use a 1 UF cap, but it's telling me to put it on the output, so I will. And it also says, these values provide a balanced tone with good low end response, clear highs, making it ideal for guitar and distortion applications. So that's what we're going to do. Move our enclosure out of the way. We have 2 sets of components. Here we have both are using this 47k resistor just because I really like how they look and Dale's a good make, it's vintage. So I'm putting that in there, that's my own prerogative and it's what I had in stock. Our 2.2 meg resistor is going to be a carbon film for that one and a carbon comp for my one. Well, I don't know how much difference that would make. I mean, as it says, carbon comps can be a little bit noisy in some applications maybe. Our input capacitors are going to be the same. It's going to be these 0.1 UF caps. Then our output capacitors, for my version, I'm going to use I've mixed some stuff up here. For my version, I'm going to use a 0.1 UF cap because that's what's on my schematic and I'm just going to follow it. And for the AI version, I'm using this 1 UF non-polar audiophile cap. I really like these. I've only got 2 left. I figured I'd use it in this build. I haven't got a 680 ohm resistor. Brilliant, well done, Joe. So I've got 2 300 ohm, 360 ohm resistors. I'm just going to put them together. It's not quite the right amount, but it's close enough. Yeah, so if you basically I'm going to put them in series so it doubles the volume. Now, transistor wise, it says 2N2222 for that. So there we go. And then for me, I'm using this 2N1711. It's got a HFE of 91, which I've wrote on the top. This actually came out of an MTPU circuit, so a motor thermal protection unit circuit for a Type 23 frigate machinery space fan. So all the circuit that this come from does is there's some thymistors inside the fan windings. When that gets too hot, it opens the circuit and this transistor is part of the switching circuit that would cut the fan out basically if it gets too hot. It's from a circuit off HMS Kent that went in the bin or in the trash, and it was getting thrown out, so I salvaged it. They're actually quite good metal can transistors. They're well over spec for what the Navy used them for, but there you go, why not? And then for clipping, so for the sake of the AI's version, it said 1N4148, I believe, yeah. 4841s, 48. Anyway, them ones, they're standard. And then for me, I really always seem to gravitate, if I'm going to have any, I prefer none, to these 1N4007s. I just like them. I normally put them asymmetrical, but just for the sake of making them the same, I'm gonna put them symmetrical just for that. And my switch, actually, this is the switch I'm going to use. It has a center position, which will be no diodes, just for something extra. But I recently had a comment on one of my videos, the Clom video, funnily enough, saying that there are no magic diodes. Well, of course there are no magic diodes. I don't think they're actually magic. I'm not going to plant them in the ground and try and grow a beanstalk. But diodes do make a difference. And what the guy was trying to tell me is that you could just set your gain at a different level and the gain is all the same. But to me, you've got things like the response time. You know, germanium would be softer than silicon. And I find that the higher the forward voltage of a diode, the different response you get. Like lower forward voltage, it gets a bit, softer. It's hard to explain. But hopefully the sound video will show the difference between these two diodes. And that'll put that argument to bed. Now I'm going to build them both on this, so 4 tags each in my circuit drawing that is on the screen now. If people want to take a screenshot of it, if I was taking a screenshot and then or even just pause the video and you can build from this if you like, if you fancy building it. But there's an extra lug on the end for the second diode. Now for me, I'm just going to run 2 wires from the very end of the circuit going straight to the switch, and the diodes are going to be switch mounted anyway, so there's no point in putting that extra lug on. So 4 and 4, and yeah, I'm going to use another one of these switches to switch between the 2 different circuits, so we'll be able to have, we'll be able to switch quickly, if you like, between the 2 of them, and we can decide which one sounds better. Am I going to win, or is ChatGPT going to win? Get on. First component today is going to be the input cap, which goes on the far left. I'm going to start left to right as ever on these tag boards. It's just the way I like to work. So because we've got a bit of space in this enclosure, I'm not too worried about the height of things. I'm going to take my flat nose pliers, just put them at the side of the component and bend the leg, and that way all of my capacitors of the same. There I am again with the oh, sorry, Anjay, he's definitely watching this going, come on, Joe, don't be saying every 5 seconds. I'm trying not to say right, anyway. They'll all be sat the same height because I'm using this as kind of a measurement. So I like to slide the component in one side all the way to the end, then snip the leg and then slide it back in, and then that way it fits in nicely. I can solder one end, lift it up straight, and then so saying it again, I won't solder this end because there's other components going in there. So if I just do the same for that one, now this is where I mess up and put it in the wrong one. So 1, 2, 3, 4 is the first circuit. This is the first this is the first tag of the next circuit. Now, as I always say, saving these little offcuts just in case there's something else that I use them for, maybe like a link or something. I mean, there isn't really on this circuit too much to link. Now, if I line them up in the center with the center holes, oops, I can just solder that in place. as such. And then when I give them a raise, they should be fairly lined up. And the same height. Ideal. Now I realise that the way I do things makes a mockery of pedal building when you compare it to something like Marcus Reeves, who has all jigs and his things. There's no tag boards. It's all point to point. It's beautifully made. Now this is as good as I can do myself, and this is pretty much what we would use in the military if we were making a circuit to last maybe battle damage of some kind. So it's good enough for me. On a side note, I've been building pedals for the longest time, but only in the last maybe 4 months did I get one of these. I don't know if anyone else uses them. So it's a little dispenser for my wire and my solder, and it's been a game changer. Like, how easy is it not to have to chase your solder around or your wire around the desk while you're building? It's insane, and I don't know why I never used it in the past, but I didn't. There you go. Anyway, now this lug or this tag is going to have the base of our transistor in there, which I'm going to put in the center hole, so it's not going to go into the same gap as our capacitor. And also we've got the 2.2 meg resistor that's going to go on the outside as well, on the outside hole, so we don't need to worry about anything else going in there. So while we're here, I am just going to solder them other legs in, wet the tip, give it a bit of a solder, just because there's no point in not doing that, because you know, might as well get it done now anyway. Right, give that a quick tidy up. Next component in line is going to be our 47k resistor, which is this. Now I know these look like capacitors, they're not. They are in fact resistors. With these old components, and I know I say this all the time, but it's a good idea to clean the legs. Sometimes I'll use a Stanley blade to clean them. Other people use sandpaper or dip it in some sort of solvent or whatever. But for me, I just with this or use a Stanley. Anyway, this is going to sit right next to it. Now, usually you want to have the component value facing upmost, but these don't have it on, just codes. So I'm going to try and put Dale facing upwards because, well, it's a brand name. What can I say? You want people to know that you're using good stuff in there. I wonder, maybe I should ask ChatGPT if it approves of Dale resistors. Maybe I'll do that actually. So there's that one, and then I'm going to do the same for the other one, for the AI side. So when you're building these, because it's upside down essentially to what the pedal's going to be in real life, your left hand side is going to be closer to your input signal. And because I feel like I'm better than AI, the competition is on, I'm going to put myself on the left, my circuit, so that then I can be first in line. Not that it's going to matter, because you know the switch is essentially true bypass, so it's not like there's going to be a buffer and anything in the way, but I want to be first, right? I do have that annoying trait that I want to beat everyone. Like, I'm always trying to get in there first. I realise that that annoys a lot of people in work. Well, it doesn't want to rest with the dial at the top on my one, so we'll give it a little. This 47k resistor here is essentially, so this is going to be the input. Next to it, this is where the 9 volts comes in. So it's just like to drop the voltage to the right level, and then it'll go into the collector of our transistor this side. So that's that, and I'm going to solder the other end in too, because same as the last one, the transistor is going to go into the center, and then on the outside we're going to have our 2.2 meg resistor and our output cap, but I'll deal with them afterwards. Next we have our 680 ohm resistor. Now I don't have 680 ohms. This is going to be over. Okay, fine. It's not going to make a difference much. What I like to do is I call it the helicopter. I know it's childish, but I put them next to each other like this, cross the two legs over, and then I just wind it. Bit like helicopter rotor blades. Fun story, I would actually never, ever, you never catch me up in a helo. Not for any amount of money. My wife laughs at me, like, all the things to be scared of, but there is no chance you'd catch me in one of them things. I'm not a massive fan of flying, but no way. So in my time in the military, we've pulled out lots of helicopters, helos, out of the water, and I don't think I've ever known anyone to survive. Like, absolutely not. I think in 2005, might have been 2004, we pulled out a Lynx, and it was the most horrific experience. You know, there was pieces of people. It wasn't like you're saving a wreckage, which we did save, but yeah, no thanks. There's just no way you get me up in one. So anyway, that's the helicopter build. Well, that's relevant to the Electra Distortion, but there you go. So after I've twisted it, I like to just give it a little wet. I mean, you could probably get away with not doing that, but it's not going to stand the test of time, is it? So you have to solder it. Now, firstly, when you go to pick this up again, almost always I'll have put too much heat in it, and the heat will still be in there, and I'll burn my fingers. I didn't this time, thankfully, which is great. The temptation is to try and snip this. I do say this all the time, so apologies if you've watched this 1,000 times and you're thinking, come on, Joe, move it along. The temptation is to snip this right close to the end to make it neat. But what happens is, almost always, is you take away the twists and they just fall apart, or after time fall apart. So I move maybe 3 or 4 mil, which is 1 or 2 turns up, and snip it there. It doesn't look as pretty. It's not pretty, but it works. And the same for this one. Now, instead of using my tool to bend a distance away for that, because they're quite tall anyway, I'm just going to bend them at the bottom of the resistors. You can literally do this any way you like. This circuit, the way it's laid out, if you're going to build a tagboard version, I do highly recommend this circuit, because it's laid out really methodical, and there's no awkward components. Not really. Everything on the tagboard is going really in a straight line. It's a great starter circuit, and that's probably why Josh Scott from JHS chose it. Great England today, Joe. Chose it as the circuit that he was going to do for his deep dive builds that he did recently, is because it's really modifiable circuit, and also it's quite simple to build. So this tagboard's nicely laid out. Whoever built this one, I downloaded it and it doesn't have a name, so I can't give credit, I'm afraid, sorry. Now, if I get both of them sort of central and get them soldered in. That's definitely not soldered in there properly. Oh, there you go. Burn myself already. Always. What are you doing? Right. That's a little lesson on how not to solder a component in. There we go. That's our 680. Now the emitter of our transistor is going to go into the hole just in front of that, but there's nothing else going into this here, so I am going to solder this in. There we go. Just tidy up these ends. Looking at it, because I'm mounting the diodes on a switch, I could have really done away with this lug entirely. That would have been helpful or handy. But what I'm going to do instead is our output cap would sit between this and the output. So the center here, and normally I leave it floating and I send it away to the output. What I'm going to do is I'm going to mount it into that position there, and I'll just run one of my offcuts go into here. It will make sense. So next is going to be the output. Of course, for my side, I'm going to use a 0.1 UF cap or a 100 NF, if you like. I don't know, what's the standard way of explaining this? Do you guys talk in NF or do you talk in UF? I tend to say NF mostly, so like 47 NF rather than 0.047 UF. I don't know. Is there a standard way? So we'll get that in there with the same sort of spacing height wise as we've done for the others. And there I'm going to go ahead and solder both sides in because there's nothing else connecting into these specific holes. Now, after the tidy up of that, I'm going to fit my 0.1, my 1 UF cap, which is the output cap for AI here. Because it's quite a big cap, it doesn't fit between the lugs. So I'm going to just go into these center holes here. And to do that, because of the space in this cap, I can just simply fold them down. And I'll have the Audiofiler brand pointing upwards because I think it looks cool. And of course, if it looks cool, it sounds better. We all know that. So it just kind of rests in there like that, and if I bend them over, I can solder them in like so. Bit of wet the tip action. Right, there we go. There's all of our main onboard components done. Next, as you could clearly see from the diagram, we're going to put in our 2.2 meg capacitor. Now, this is going to be the one for my one, which is a carbon comp. I don't think this is going to make much difference really. So all I've done is manipulated the legs into a V, and then I'll just push them through the two lugs here. And then all I'm going to do is solder in this side leg here, because we want to put our output cap, this one here, go into this side. So I'm not going to solder that in yet. I'll just solder in this one. I've got some space in the enclosure. It doesn't matter how much I overhang this. Of course, some people think shorter leads, less noise and stuff like that, but for this sort of build, I don't think it's going to make all that much difference. Not to my ears anyway, and that is not in any way me saying it doesn't make any difference, because my ears are not great from 20 odd years of being in machinery spaces. So, fun story though, my hearing's actually improving. I thought I was going deaf at one point. I genuinely thought I was losing my hearing. I had a constant whine, which I still have actually, tinnitus, but I had a constant whine in my ear, and I was convinced that I was going to lose my hearing. I had the hearing age of a 60-year-old or 50-year-old? Anyway, when I was like 29, it was ridiculous. However, since I've not been serving on ships and I've been shore-based, I'm looking after my hearing a bit better. It's actually improving. So there's light at the end of the tunnel there. Right, so for this one, I'm just gonna solder the one side in again, because again we're going to want to attach our output cap to here to make the circuit. So I am going to snip him short. Not that I needed to. Now I'm going to use one of the offcuts to go from our output cap to here, and that will make the other side of this output cap right here the output of our circuit, but we'll look at that once it's inside the enclosure. Now this is why I like these flat nose pliers. They're great for this sort of thing. So I'm going to put a bend in it so we can go in here, and then if I place it in place where it's going to go, I can grab, I don't know how you see this on camera, I can grab this at the point where it's going to go into the lug that I want it to go into, and that way we're just getting sort of right angles and it looks nice and neat. Now I like to make one of the legs longer, so then you're not trying to push two legs through two holes at the same time. It doesn't really matter. If you've measured it properly, it should be pretty easy. So here we go, we can solder both sides of this now. So it's soldered properly, let's give it another go. As our diodes are going to be on the output side, it doesn't matter because both sets of diodes are going to really work for both sides, even though when we do the test, I'm at first going to test the diodes with the correct circuit, if you like. But these will go to the output, they'll go through our switch and then to the output. Both of them will join into the same point of the switch. But I'll show that as we wire it up. So let's get the other leg in. Well, hey, the other leg. So that's what I mean. I like to have one, can you see that? One leg longer than the other. So then when I'm slotting it in, I can put this leg in first and then just flick this leg over and go, and that will go in as well. There we are. And that just joins our output cap to the collector of the cap of the transistor. One thing you've got to remember with this, usually you have emitter collector base is the lineup of legs on your transistor, but this goes base collector emitter just because of the way that the circuit's orientated. It doesn't matter to the tone, but it is one thing that you've got to think about, the pin out of your transistors. Now here's our transistors. I'm going to deal with the AI one first just because it's a nice easy, it's got longer legs. Now for this, what I use, and I'm sure everyone's seen this a million times before, is a DCA 55. These things are really handy, these little clips, but they fall off so fast, and so I've had to do a battle damage repair to one of them, so it's just got a crocodile clip on there. Brilliant. In fact, it happened during a video while I was complaining how crap these clips are. One of the clips fell off, so I had to repair it. So if we turn that on, and low battery, brilliant, well done Joe. Now it tells us that it's an NPN silicon transistor, and it tells us that the red lead is the collector, the green lead is the emitter, and the blue lead is the base. If we keep going through, it'll tell us our current gain, HFE. Now that tells us how much gain it's got. Germaniums tend to be lower gain, but most silicons are around about this 300, 200, 300 gain. This one's actually 91. It is a silicon because, well, I don't know, it's an older one, whatever. So the gain will actually make a difference, and I'm sure we'll hear it. But anyway, the rest of it, you're not going to get any leakage on a silicon transistor because they don't leak. It's only germanium that do. Someone's going to prove me wrong there, I'm sure. So red is the collector, which wants to be our center pin on this circuit. Green is the emitter, which goes on this side. And blue is the base, which is currently in the center. So what I'm going to do is I'm going to swap these two legs over. So then we have our base on this side, collector in the center, and emitter on the end. Now to stop these legs from touching, what I like to do is I just take a little bit of the shielding, if you like, or the silicon off my cable, wire, whatever, and just slide it up that middle leg. Now you could cover all of the legs in this if you wanted, but for me I'm just going to do the one. I like to do the center leg as well, just because then it's even, whatever, it doesn't matter. As long as them two legs cannot touch each other, you're all good. And then look at our circuit. The base goes into our input cap. Our collector goes into the 47K and also the little link to our output cap. And then the emitter goes into our 680 ohm resistor right here. Now, I am just going to solder in all three of them. It's probably advisable to solder one. If you're using the center bit here, you're putting quite a bit of solder in, which means you're putting quite a bit of heat. So it's usually advisable to solder one at a time and then wait a second for it to cool down. What I like to do is I get one leg in and then position the transistor so then it's straight, but bend it forward out the way. Then I can get a bit of wet tip on the go and just fill in the other two. Now you don't want to be holding it on there too long because it can damage it, but silicon, especially new silicon, are usually a little bit more hard wearing than germanium, so you can get away with putting a bit more heat in there, and then afterwards you just straighten it up, and that way you can see it's fairly straight. Now for this one, it's going to be an absolute pain, because if the legs were base, collector, emitter, it could just slot straight in brilliant, because I reclaimed it off a circuit, they're only short. So we're going to have to get around that, but beforehand, let's check, just see if it is base, collector, emitter. I might get lucky, I don't think so, but... And because I've got this crap crocodile clip, I literally can't grip the bloody thing. There we go. Let's see where we are. NPN silicon transistor, yes, we know. So we've got red is the emitter, green is the base, and blue is the collector. So we are going to have to extend the legs. And if we keep, I went past it, well done, Joe. We keep going past it, it's now 101 HFE. That obviously read 91 last time I tested it. That'll probably be something to do with the battery running low on this, but it's close enough for government work. And again, leakage current is 0 because it is silicon. Now, to do this, I'm going to use the hook and loop method that I use on all of my, if I want to extend any sort of lead. So I bend it round like that and make it a little hook. And then I use one of my offcuts, told you these would come in handy, to make another little loop. And then just marry them two together, as so. And if you dangle them down, and the one that's in your hand, whether you're holding the transistor or you're holding the extra leg, just use your snips to crimp that together like this. And that way you get a good solid mechanical connection to hold it in place. Last time I did this on a video, I said a good solid mechanical connection as the thing fell apart right in front of me. Well done, Joe. So wet the tip and then just give it a quick dab of solder, and that's enough to hold it in place. And there we have our extended leg. That way I can cross them over and cover one in silicon or heat shrink, probably because of the lump in it. And that way we've got longer legs on our transistor. I'm going to go ahead and do that now. We have all three legs now extended. Just to show a different method of covering the legs, This time I'm going to use some thin heat shrink. I'm just going to slide all 3 legs, or slide all 3 legs, cover all 3 legs with heat shrink. And then you should really use a heatsink, but I'm using this set of snips as the heatsink by holding one leg. And I'm going to use my lighter to melt the heat shrink, shrink the heat shrink. And I know I should use a heat gun. I'll get in there before you all start writing in the comments telling me how bad I am. And I just like to use this because I say it all the time, but on board a warship, the tools are kept on 2 deck, which is, you know, you could be working on 5 deck, the other end of the ship, and to walk that length, go and find a tool and then walk all the way back, carry it through all them clipped doors and up ladders. It's just a massive effort when I could just have that in my soldering kit bag. And there you go, I've got it with me and it's done. Now the reason why I used heat shrink instead of just a bit of the cable cover, sorry, the wire sheath, if you like, is because the solder lumps on this, with me making a mechanical connection, are larger than if I'm just covering the leg on a normal transistor. So there we have it. I'm going to go ahead and find out which leg is the collector base emitter, swap them over, and I'll get it installed. Then we have all of our on tagboard components in place. We've got my side with the carbon comp, 2 0.1 UF caps, input and output, and the reclaimed military spec silicon transistor. And then the AI side with a 0.1 UF input cap, same as mine, a 1 UF, a whopping cap on the output, and a carbon film resistor here with our 2N2222 transistor. At this point, I'd like you to write in the comments who you think's going to win, me or ChatGPT, on this sound test. I'm quietly confident, but who knows. Now, we move that to one side. Next step is going to be wiring in our diodes. So here's my side and here's ChatGPT's side. What I like to do for wiring in diodes, I mean, you could wait until it's inside the enclosure, but for me, what I like to do is I take my switch. Now, you could use a double pole, double throw switch. That would be probably way easier than using a 3-pole double throw, and cheaper, but I add these to hand, so I'm just going to use them. Now, with our diodes, as you can see on the diagram from the beginning, there's a little black line on the diode, and that's got to be pointing in the opposite direction, so they've got to be crossed over. Okay? Now there's all sorts of ways that you can fit these. For me, I just do the same helicopterish type thing. First of all, before I get in there, I'm just going to give them a quick clean, because I can see they're a bit dirty, and although I don't think it'll affect the solder joint, who knows, it may do. I don't want ChatGPT having an excuse when my side wins, you see. Right, anyway, so I'll just hold them together so they're so then they are level, and then I'll do my little helicopter thing, but only 1 or 2 turns this time. In fact, I may have done too many on that one, and that is because I'm going to use the legs to go into the no, that's pretty perfect, to go into the lugs on the switch. So if I lie that there and then do the same for my ones, the legs on these ones are a little bit more robust, because these are actually designed for AC to DC power regulation, so as a diode rectifier type thing. Anyway, so these can handle like massive voltages compared to them. So we line them up so they're in different directions, because if you put them in the same direction, they're both going to be clipping the same half of the signal. Now, I have explained that in a Tube Screamer video that I'll link above now. Just give it 2 turns on each side. Now, most pedal builders, especially professional pedal builders, will have some sort of handy arms that hold components for them when they're soldering. But here at Hello Taylor Effects, we we like to do things the counterless way with no arms. So all I'm going to do is I'm just going to do the same thing as before with like our transistor legs, just wet the tip and a tiny dab. What I like to do is do one side of one side of the other. That gives it a chance to cool down, and then do the other side. And then that way you're not smashing too much heat into the diodes all at once. And usually I pick them up straight away when they're hot, as I've said, and burn my fingers like I have already this episode. All you have to do now is trim off one half of the off-cut legs, and you've got right angles ready to go in our switch. If I can ever get them in, well done, Joe. So there we go. Let's go ahead and solder them in place. If you're worried about getting dripping solder or heating up this switch too much or dripping solder on your enclosure, don't use your enclosure. But I've been doing this for a long time and I've never had a problem yet, so that's the way I do it. I'm sure someone will tell me off in the comments. Love it. I've got to say, if anyone disagrees with anything that I'm doing or the way that I do it, please do write in the comments, because I love the discussion over it. I've had some wonderful discourse come out of people telling me that I'm wrong, which is great, because, you know, I've been doing this sort of thing a long time in a Navy situation, so I may well be wrong in an electrical sense or for like consumer electronics. But if your pedal ever gets battle damage, you'll be glad that I bodged it. Anyway, let's get this one soldered in. As I say, you can do this when it's inside the pedal once you've fitted it, but it's just easy to have the space. So that's all of our soldering outside the enclosure finished. Next, I'm going to go ahead and install the jack and the jacks and the switch and what have you, and a power socket, and we'll catch up after that. Our enclosure is now fully populated. We've got our skeleton jacks, or the old switchcraft style jacks at the back here. Power socket. This is going to switch between our two halves of our circuit. Then this here is going to switch between our two sets of diodes. We'll wire that in later on. 100k log output on the output for our master volume. Yeah. Now, what I have noticed, and I'm probably going to mess up a couple of videos now, is that I haven't brought my LEDs with me. So anything to do with LEDs I don't have here, so I can't fit any LEDs, unfortunately, which is a nightmare. I was kind of rushing when I was packing my bag for work, because I am duty. So I'll fit them when I get home before I do the sound sample. Now, first things first, I'm going to wire in our signal. So the input and output. Now, the input of our circuit is going to come from this lug here, because that's our input jack. So this is going to be the input to our circuit. I'm going to run a wire from this round here and into the center lug here, and then this switch here, when it's in the up position, it'll, you know, when this lug's selected, sorry, that'll run to one half of the circuit, and when it's in the down position, this will run to another half of the circuit. So it'll either be the ChatGPT circuit or my circuit, all connected to this one. I've now wired in our input, so it comes from the input of our 3-pole double throw stomp switch, center lug of our selector switch to go from the top lug here, which will be the down position on the switch. It comes round and goes into this circuit, which is my circuit, and then if we go up on a switch, it selects this lug here, which sends it down, round, and into this circuit, which is the ChatGPT circuit. Now I'm going to do the same thing, only for the output. And if you remember, these are our output caps. This one here and this one here. So it means that this will be my lug, and this is ChatGPT's lug. I was just about to say that's the output side now wired up and ready to go, but that is absolutely wrong, because what I've done is I've wired both of our output caps going to the correct bit of the switch, but then I run a switch round here to our output. That was totally taking out the master volume, so we would have had no volume control on our Electra Distortion. So this wire here actually has to go to the first lug here on our pot, and then the center lug of our pot is going to come round and attach to here, and the last lug of our pot will go to earth, but we'll deal with the earth later. I'm going to reroute this wire now. Now we have our output wired up. So it comes from our output caps, various, through this switch and round to our pot, out the pot and back round to here. Next in line is going to be the 9 volt, which is here and here. So all I'm going to do is I'm going to jump a wire from here over to this, to then these two 47K resistors are joined together. Then I'm going to run that right the way around the back to keep it out the way and run it to the 9 volt part of our DC jack. Because we're not running a battery, I tend to join both of these 9 volt lugs together, and I use one of them for our LED and the other one for our circuit. So what I'll do is I'll make the wire just a little bit longer so it pokes through this one here and then rests up against this one, so I can solder them together later on when I finally do fit the LED, because of course I forgot to bring them. 9 volt is now wired in. I've just left it resting against that other pin because I'll run a wire around the back here and to our LED, and then I'll run a resistor from the LED to the switch, just because for current limiting. But I can't do that obviously because I forgot it. So next part of this is going to be our ground. Now the things we need to join to ground is this lug here on the jack, on the DC jack, is our ground. That's going to go to this and this pin here on our output jacks. Now a lot of people just do one output jack or connect to ground and then use the fact that this is actually touching the enclosure as a ground. I like to solder them both just so that I know that they're touching ground. So I'm going to run a wire around here and through to this one. Then it's also going to come round and attach to this lug here on our pot, and that's because that gives, on the output, when we're reducing volume, we're actually bleeding signal to ground. That's how we reduce it, so it'll go through there. I'm also going to take a wire round here and run it to this pin here on our 3-pole double throw switch, and that'll ground out the LED when we're not using it. Sorry, that'll be the ground for the LED when we are using it, not ground out when we're not using it. What a stupid thing to say. So that's going to be the ground lug for our LED. Then we also need to think about the diodes. So our diodes are wired on this switch right now. One side of this switch is going to go to our circuits, which is the 68 ohm resistor here. So we're going to have a wire that comes round and goes to here and also to here. So when we switch to each of these diodes, we can actually use them. Then this pin here is going to go to ground. So all I'm going to do is use one of our offcuts and raise it up and just attach it to here while we're here. That'll be nice and easy to do. I'm going to go ahead and crack on with that. My ifs are all wired up. I actually think I misspoke before. So this side of our diodes is wired to earth, and then our earth wire comes round, joins our two jacks together round here. One goes to here for our LED as stated. Then we come round here and we go into the lug number 1 on our volume pot and the two 680 ohm resistors. That's all of our earth. Now the other side of our diodes would normally go to our output cap. So it would normally connect to our output cap if there was just one single circuit, but because there's two circuits, they join together at this point. So I'm actually going to connect the diodes to either this lug here on our switch or the first pin on our pot. I may go for the pot because there's a bit more space to solder here than up here, although That means running a bit of a longer wire. It's a bit of a trade-off. Actually, while I'm speaking about wire, most of you will no doubt have noticed if you watch my show all the time, I'm not using pink wires today, and that's because they've actually run out of pink. The place I buy it from only had either grey or, I forget what the other colour was, maybe it was yellow. There's grey or yellow, so I went with Battleship Grey. I mean, it's the next best thing to pink I can think of. So that's why we're using grey this time round. Now, I'm going to run the next wire from here. I took it right the way around the back here, and I'm going to put it into this lug here. And that means that both of our circuits use this pot, so both of our circuits will be able to use our diodes. That's our diodes now wired in. The final thing is to run from this lug here to the input jack, this lug here to the output jack, and of course the loop that I always forget, joining these two together, and that will be our basic bypass signal wiring complete. All I'll have to do is when I get home I will wire in the LED, and then we'll have a sound sample. That's us fully wired up with the exception of our LED. I've also added in the pot. I went with these old school Bakelite, I don't know what did they used to come on, like the Neve consoles. Now, as far as the switching goes, with this switch in the down position, it is my circuit. Up position, ChatGPT. Down position is going to be for me, and then diode wise, I couldn't get my words out then. Diode wise, it's going to be the opposite, which is annoying. So up position is going to select the Hello Sailor diodes, and down position is going to select ChatGPT. So you're going to have Hello Sailor, ChatGPT, and then we'll see how well, in fact, we'll change the diodes over to different positions and see which set sounds better with which circuit, and the master volume will work for both.
And now on to the sound sample. You're going to hear my version against ChatGPT's version, and I'd love to know in the comments which version you think's better, and I'm going to announce who wins, me or ChatGPT, during our next Pedal Dive podcast. Please be gentle to me. If you enjoyed this video building the Electra Distortion on a tagboard, you're going to love this video on how to build an Abbey Road fuzz from scratch.